Hello students, welcome to all. Again, today we are going to continue Ncert Exemplar series of class 11. So let's start the class. First question is which of the following are not a unit of time? So we know that second is unit of time, parsec is the unit of distance, and year is the unit of time. Light year is also unit of distance. So not here option is not, so the right answer will be option B and D. And you have to remember here that parsec is the largest unit of distance, after that light year, after that astronomical unit. So you have to remember this sequence. Next one, which of the following ratios express pressure? Some questions may have multiple options, multiple corrected options, so you have to check all the options carefully. Here force by area means pressure, so obviously this one is pressure. Now you may check also by dimension, but here we will do like that: pressure equals to force by area. So if we multiply force by displacement, and it is also by displacement or distance, then this can be written as work done, and this can be written as volume. Work done means energy, so energy by volume is also pressure. So option B is also correct. Now option C is energy by area. We have already find out that energy by volume gives pressure, so obviously this one is not possible. And the last option is force by volume, so it is obviously not possible because we already find that force by area gives pressure, so it is not also possible. So option B and A are the correct. Next question. If Planck constant and speed of light is vacuum are taken as two fundamental quantities, which of the following can in addition be taken to express length, mass, time in terms of three chosen fundamental quantities? Here H and C are given as fundamental quantities, and you have to add another one among these options so that we can derive M, L and T as derived quantity. So obviously mass has the dimension of M. This one is also mass, so it will also be M. And charge of electron has the dimension of AT, because Q equals to I by T. Then we can write I equals to I equals to Q by T. Then we can write Q equals to IT. So I has the dimension A and T is T. And gravitational constant G can be derived from this formula: F equals to G m1 m2 by r square. So G equals to F r square by m square. So F is m L t to the power minus 2 L square by m square. So it will be m to the power minus 1 L cube t to the power minus 2. Okay. Now this one is possible because here mass, here the dimension is mass. This one is also possible because it is also mass, and here also mass, length and time, this one. But in this option one additional quantity is present, that is current. In this in this quantity there is no current, so it cannot be expressed in terms of charge of electron. So here the right option will be A, B and D. Next one, photon is a quantity of radiation of energy E equals to h nu. Nu is the frequency, h is Planck constant, the dimension of H as the same of. First, we should find out the dimension of Planck constant H. Let's use this formula. So H equals to E by nu. Here nu is the frequency. Energy has the dimension of ml square t to the power minus 2, and energy means 1 by time period, so it will be 1 by time, that is t to the power minus 1. Then the dimension will be m l square t to the power minus 1. Now check, there are options: linear momentum, angular impulse, and linear impulse. So linear momentum means actually change of linear momentum. Linear impulse means change of linear momentum. So this one and this one is same, and angular impulse means change of angular momentum. So this one and this one is also same dimension. Okay, now we have to check which one has the dimension of this. First we will check linear momentum. Linear momentum means mv. So m l t to the power minus 1, this one will be the dimension of linear momentum, but it does not match with Planck constant, so it is not possible. That means linear momentum is not possible, and linear impulse is also not possible. Now if we check uh, angular momentum, then it is mvr. So m l t to the power minus 1 and r is l, so it will be m l square t to the power minus 1. This is same as Planck constant, so it is possible. Then the right answer is option B and option D. Okay, next one: on the basis of dimension, decide which of the following relation for the displacement of a particle undergoes SHM or simple harmonic motion is not correct. Okay, now we know that sine, this trigonometric function, has no dimension. Then it is amplitude, so it has dimension of distance or displacement. So this one is correct, because y is also displacement, so it is length, it is also length, so this one is correct. But if we check next option, y equals to avt, then sine function has no dimension, then it is also length, so this one is also correct. Now if we check option C, then y equals to a by t, but we know that a has the dimension of a, so it is not possible. Y has the dimension of a, so it is not possible. And if we check the last option, d equals to a root 2. Okay, sine has no dimension, cos has no dimension, so it will be the y equals to a root 2. So y has the dimension of a, and here root 2 is constant, so it is not a factor, so it is also correct. So option not correct, that means C is the right answer, so it will be C. Option C is the right answer. And number 14: if p, q, r physical quantities has different dimension, which of the following combination can never be a meaningful quantity? So this is a conceptual question. So if we apply the principle of homogeneity, then we know that physical quantity having same dimension we can add or we can subtract, but different physical quantity with different dimension we cannot add or subtract. So option A is not possible, because p and q both have different dimensions, so it is not possible. And the last option is also combination of addition only, so this is not possible. If we multiply two different physical quantities, we cannot say what will be the dimension of this quantity, so it may be meaningful. but if we direct add or subtract of different dimension, it is not possible. Okay, so option A and E is the right answer. The next one is, if momentum, area and time are taken to be fundamental quantities, the energy has the dimensional formula of. Okay, here energy is derived quantity and you have given that momentum, area and time is the fundamental quantity. So if we denote energy as E, then we may say that energy is proportional to p to the power alpha. We don't know the dimension, so we can take it alpha. Okay, area to the power beta and time to the power gamma. Now energy has we have taken constant as 1, so it can be replaced by equal sign. Energy has the dimension of ml square t to the power minus 2. Pressure has the dimension of force by area. Force ml t to the power minus 2, area is l square, so it will be m l to the power minus 1 t to the power minus 2. So we may write like that: m l to the power minus 1 t to the power minus 2 to the power alpha, and a is length square, so it may be written as beta, and t is t, so it is gamma. Okay, this one is length, gamma. Now m alpha, m to the power alpha, l minus alpha, and here 2 beta, and t to the power minus 2 alpha, and this one is gamma. Now if we make both sides equal dimensionally, then we may say that m has dimension here 1 and here alpha, so alpha is 1. If we take next one, then this one will be equals to this one, so alpha plus beta equals to 2. Alpha put here minus 1, so it will be 2 beta equals to 2 plus 1, that means 3. Then beta will be 3 by 2. Okay, then beta equals to 3 by 2. And the last option, this one will be equals to minus 2, so 2 alpha plus beta equals to minus 2. Then gamma equals to minus 2 plus 2, minus 2 plus 2, minus 2 plus 2, that means 0, gamma is 0. Okay, gamma is 0. Then we can write, sorry, here uh, time, how many times this one, length is this one, so I think I have made mistake. So ml square a and ml l square t gamma, t gamma minus 2 alpha plus gamma, uh, minus 2 alpha plus gamma. So this one is minus alpha. Okay, then minus alpha plus beta equals to 2, so it is correct. 2 beta equals to 2 plus 1, that means 3, then beta will be 3 by 2. um, sorry, this one is momentum. Okay, we have taken it as pressure, so it is Here P is expressed as momentum by I have taken it wrongly. P as pressure. So energy equals to momentum to the power alpha, area to the power beta, area to the power beta, and T to the power gamma. Energy has the dimension ml square T to the power minus 2. Momentum means mass into velocity, so it will be alpha, and area is L square, so it will be L square and T to the power gamma. Now make both sides equal dimensionally. So m has dimension here 1, here m to the power alpha, L alpha plus 2 beta, and T to the power minus alpha plus gamma. Okay, now here alpha is 1, so both sides if we make equal, then alpha equals to 1, this one. Next this one is equals to 2, so 2, then 2 beta equals to 2 minus alpha, that means 1, beta equals to half, and if we solve this one, minus alpha plus gamma, it will be equal to minus 2. So minus 2, gamma equals to minus 2 plus alpha, so it will be minus 1. Okay, then energy can be written as P to the power alpha, that means P to the power 1, A to the power beta, that means A to the power half, and T to the power gamma, that means T to the power minus 1. If we rearrange it, it may be written as P by T, and it will be root over of A. So it will be the right answer. Okay. Okay, that's all for today. We have completed all the MCQs from chapter 1. If you are new, please subscribe our channel. It will be helpful to all.